Chapter 14, Day 2, Two-Way Tables. We learned about these quite a while ago. Remember margins, stuff like that. So we're just going to take a real quick look at that. These are R and C tables, is what they're also called. What that means is rows and columns. So let's say I give you some data for stuff. And the data looks like this, 5, 3, 2. And I give you some more data, more stuff. Clearly when I made these notes a couple years ago, I was feeling the drain of teaching AP Stats at the time. More stuff, 1, 7, and 9. When we're dealing with a two-way table, what we really are concerned about oftentimes are the margins. Well, margins are important. So this would be the total of the rows. So 5 and 1 is 6, 3 and 7 is 10, 2 and 9 is 11. And this would be our total column. So 5 and 3 and 2 is 10, 1 and 7 and 9 is 17. And what goes in over here? Call it the grand total, but it's the total of the columns, the column total, or the row total. It's actually and, it's the same thing, but it doesn't matter which where you get it. It's basically everything in the table added together. So 27. You should get 27 down or 27 across. How's that for a review set of notes? That's it for notes today. Okay. I expect that you know this. So we learned it last fall. I expect that this is something that you're familiar with for the most part. So let's look at a problem. Number 1411. This is the smoking problem. How to quit smoking. Anybody that's ever tried will tell you that the best way to quit smoking is to never start. I think you've heard my story about that. So it says that it's hard for smokers to quit. Perhaps prescribing a drug to fight depression will work as well as the usual nicotine patch. Perhaps combining the patch and the drug will work better than either treatment alone. Here are the data from a randomized double-blind trial that compared 4 treatments. A, success means that the subject did not smoke for a year following the beginning of the study. So we have some data here. We've got treatment. And subjects. And successes. So the treatment, the first treatment is the patch. I'm just going to refer to that as N in the future. And 244 subjects tried out the patch alone. And of those 244, 40 were smoke-free a year later. The drug, which is called D, we also had 244 smokers try the drug, and of those, 74 were still smoke-free after a year. the patch and the drug, we had one more, 245 tried that. Oops. And 87 were successful combining the two. And lastly, no observation would be good without some sort of a placebo. And we had 160 with the placebo, and of those, 25 were still smoke-free after a year. So it says summarize the data in the two-way table. So I'm going to total this. 244, 244, 245. I don't know what that is. I get 893. 893 participated, and 40, 74, 87, and 25 were successful. 226 were successful. I don't really see, adding the rows as being anything that would be of value here in this case. So the only thing I can see value in is the columns. So I'm going to leave the rows alone. What you could do is you could say how many were failures, which would be 244 minus 40 and so forth. But again, I don't really see a benefit to that, at least at this point in the problem. B. Says, calculate the proportion of subjects who refrain from smoking in each of the 4 treatment groups. So the proportion that take and use the patch is going to be 40 divided by 244 for a 0.164. So about 16% were successful with the patch alone. P hat, the drug alone, is 74 out of 244, which is a shade more than 30%. And the proportion of people who took the drug, the patch and the drug, was 87 over 245, which is a little bit more than 30%. It's almost 36%, about 3.355. And lastly, the placebo group. Poor saps. Here you go. Here's a drug for you. Try to quit smoking. 25 out of 160 is about 16%, 0.156. So the next thing is it says make a graph to display the association. I chose a bar graph. I'm going to sneak that in here on the bottom of this page. Doesn't have to be too big. My largest proportion was about 36%, so I'm going to count by 10%. Success. And the type of treatment For the nicotine patch, we had a little bit more than 16%. I'll draw a bar graph that's about like so. And then we had the drug, and that was about 30%. And then we had the patch plus the drug. It's a bit more than the drug alone. And lastly, we had the placebo. It's just a shade less than the patch. I think I want to be the placebo manufacturer. Just give people sugar pills and charge a lot for it, right? That'd be sweet. So what do you notice? Any observations? Yeah.
The nicotine patch is affected.
It's maybe not affected at all. The numbers are awful close. Yeah. Or at least it's not more effective than a placebo. Somebody thinking they're getting something. Right. Yeah, I agree. So yeah, the patch and the placebo doesn't seem to be a good direction. Anybody see anything else? The patch was more noticeably effective when it was combined with the drug, but the thing that strikes me is I would assume that these people are motivated in some way to quit smoking. I know for me, because I'm cheap, it would be because I'm spending, what, $5, $6 a pack? I don't even know what it is now. It's not cheap on cigarettes. So I'm just looking at it and going, really? A drug and a patch? And we've only got 35% people being successful in quitting smoking? That's tough. I think that tells me that it's not an easy thing to do. All right. Moving forward, where am I at here with my notes? D, we need to write the null and alternative hypotheses. The null hypothesis here is that it won't matter what the treatment is, whether it's the patch, the drug, the patch and the drug, or the placebo. So I'm going to say that the proportion of those that take the patch, that get the nicotine patch, equals the proportion that get the drug, equals the proportion of the patch plus the drug, equals the proportion of the placebo alone. So what's the alternative? It's always the same in chi-square, pretty much. At least one will be different, yeah. At least one will have one treatment. At least one treatment will be different. I mean, clearly, they are different when you look at the data, but are they significantly different? And that's where we're going. So we have our observed how many were cured, I guess you'd say. So here we have our observed. We need to calculate our expected. If all of the groups are the same, then the proportion or the number is going to be 226 divided by 893, the total number of successes divided by the total number of participants. So our expected proportion is success over total, and that is 226 over 896, which I have down as about 25%, about 0.253. Now that percent is, we've got counts here. I can't compare these to a 25%. So what I have to do for the patch is I take how many were in the patch study times the proportion that we expect to get my expected value, my new expected value. So this should be 61.7. I seem to be, at least I'm catching it, I seem to be writing my numbers backwards today. Maybe that's every day. So the expected value, the expected number for the patch and the drug is the same, since we've got the same number in each group. For the drug plus the nicotine patch, that's 245 times 0.253, which changes this just slightly to 62%, or 62, sorry, not percent, these are counts. And for those that got the placebo, we had 160 in that group, times 0.253. Now if you'll remember, our observed cannot be a decimal or a fraction, but our expected can. So at this point I've got everything that I need for the goodness of fit test. So I'm going to go to that. And I'm going to clear my lists from the previous problem here. And I'm going to put in our observed. We had an observed number of successes of 40 for the patch, 74 for the drug, 87 for the drug and the patch, and 25 for the placebo. And now I'm going to put in my expected for L2, 61.7, another 61.7, 62, and what do we have? 40.5. Now we let the calculator do the work. We're going to go to our tests. Up is the quickest way to the goodness of fit test. It's D. Observed is L1. Expected is L2. Degrees of freedom. 3, yes, 3. Oops, wait a minute, I don't want that. L1, degrees of freedom, 3. And calculate. So chi-squared equals 26.0, it's actually 26.1 would be rounded correctly. And p-value, 0.000009, 5 zeros and a 9. Degrees of freedom, 3. And those other numbers, those are our chi-squared values for the individual tests, but I don't think we need those. Yes.
So when we get like the e -6, like the exponential -6, do you want us to write it out like a different calculator, or do you want us to start doing zero?
I don't care as long as it's written either way. Whether you put it in the exponential form or not exponential, but scientific notation. I like to put the zeros in there myself, just because, I don't know, to me it highlights what's really going on. But I don't have a preference for you.
Okay.
Whatever your preference is. Fair question. Okay, so with a p-value like that, do we reject the null? Absolutely. Yeah, it's approaching 0. So we reject the null. We have I can't say that word today. Have significant evidence at any reasonable alpha to reject the null and conclude that there is a difference in at least one treatment.